right, here's a little how-to on A1. We've done 1 through 5 already. Those are just the ones where you're solving for velocity or kind of the basic motion solving ones. Now with 6, you can see that we are solving for average acceleration. So in order to find acceleration in this case, we're going to need a final velocity, initial, and some time, because our handy-dandy acceleration formula is final velocity minus initial velocity, all divided by the time that goes by. So in this case, which one is our final velocity and which one's initial? Well, it says a car speeds up from 4 meters per second to 35 meters per second. So if we are speeding up from 4 to 36, the 4 is going to be our initial velocity, while 36 would be our final velocity. And this all occurs over a 4-second time interval. What is acceleration? Indicate positive or negative to show direction, because we don't have north, east, south, west. Just positive or negative for direction. So final velocity, let's plug that in first. And here's where most people mess it up, is because they'll put in 4 minus 36. And if you did that, you would get a negative number, and that would indicate that you have negative acceleration. But also one thing you notice is that you are speeding up. So we should not be getting a negative number for an answer. We should have a positive acceleration since we are speeding up. And in this case, yes, we have 36 as our final velocity, and minus our initial velocity, which was 4, divided by the time that goes by, which was 4.0 seconds. So if you do that top part, 32 meters per second divided by 4.0 seconds, and you would get your answer. And technically, since we are solving for acceleration, remember your unit should be meters per second squared. Because you can see here you have meters per second on top, and you're also dividing by that second. So you technically could also say meters per second, but let's just do meters per second squared. If you did this, though, it's still correct. And then your answer there for number 6, I'll let you guys get that one. 32 divided by 4. Might even be able to do it in your head. All right, number 7. The same race car slows down from 36 to 15 meters per second, and this now happens over the course of 3 seconds. What is the car's average acceleration in this situation? So immediately now you see that that car is slowing down. Anytime you see that something is slowing down, you're likely going to have a negative acceleration, or negative A. And in this case, let's figure out if we do have a negative acceleration. Well, it says we slow down from 36 to 15. So we're starting at 36, so that's our initial, and we slow down to 15, so 15 would be our final velocity. So set it up again how we did before, Vf minus Vi all over T. Final velocity was 15 meters per second. Our initial was 36 meters per second. This all occurs over a 3-second time interval. And then you can see on the top, 15 minus 36, that answer on the top is going to be a negative number, whatever it may be. And then you're dividing by 3 seconds. And so you know that your answer is going to be some sort of negative acceleration there. And I'll let you guys get that one. But yeah, negative answer, whatever it may be. And we are in meters per second squared. Okay, number 8. A car is coasting backwards down a hill, hence the negative acceleration that you see, the negative velocity. When the driver decides that it is a bad idea and decides to finally drive uphill properly, after 2.5 seconds, the car is moving uphill at a velocity of 4.5 meters per second in the positive direction. What is the car's average acceleration? Okay, same thing, positive and negative for directions of acceleration. All right, so we know that the car originally is coasting at -3 meters per second. I don't have too much room up there. I'm just going to go velocity. Initial velocity is that negative 3.0 meters per second. Our final velocity is that positive 4.5 meters per second. And we also know that 2.5 seconds go by. So our time is 2.5 seconds. So our formula, VF minus VI, all over the time. In this case, our final velocity was the positive 4.5 meters per second minus the 3. So now in this case, since you are subtracting a negative number, negative 3 meters per second, technically you would add this top row. So 4.5 plus 3, I'm going to give you 7.5 on the top. We're still dividing this by 2.5 seconds because that is how much time goes by. And so 4.5 plus 3 equals the 7.5 meters per second. And you got to divide that by 2.5 seconds. And your answer is going to be in meters per second squared. Awesome. All right. Number 9, dealing with some golf balls. A golf ball rolls up a hill towards a mini golf hole. If it starts with a velocity of 2 meters per second in the positive direction, and it's accelerating at a constant rate of negative 0.5 meters per second squared. We've got two things we want to figure out. A says, what is the ball's velocity after 2 seconds? And then B, we want to know what is the velocity after 6 seconds. Awesome. So when you set this one up, let's first figure out what we know. We do know that it starts with a velocity of 2 meters per second. So when it's saying starting with a velocity of 2 meters per second, that is our initial velocity. And it's accelerating at a constant rate of that negative 0.5 meters per second squared. So we technically know that our initial velocity is 2 meters per second. We also know that our acceleration is negative 0.5 meters per second squared. And what we don't know is it's saying, what's the ball's velocity after 2 seconds? Well, that means that our time here is going to be 2 seconds, or 2.0 seconds. And technically, since we're wanting to know what it is after the 2 seconds, our unknown is our final velocity. What is our final velocity after 2 seconds? That's the question. And then that problem B there is going to be set up almost identical, except for your time is then going to be 6 seconds, but everything else would be identical or be the same. So with number 9, let's figure out what formula we are going to use. And since you are technically solving for final velocity, let's do that. So the way you're going to do it is use, let's go, VF, for final velocity, equals your initial, lost the I there, plus acceleration times time. So VI plus A times T. Awesome. So let's plug in our numbers there. Plug in VI, which is 2.0 meters per second, plus acceleration, which in this case is, well, let's go like this, negative 0.5 meters per second squared. And you want to multiply that by your time, which in this one is 2 seconds. So order of operations, multiply those two first and then add it to 2. And that will be your final velocity. And since it's velocity, it's not squared, it's just simply going to be meters per second. And it looks like hopefully you're going to get a velocity of positive 1, it looks like. 1 meter per second. Awesome. Oh, wait a second here. Yeah, so how did you get that? Well, you got 2 here, and technically negative 0.5 times 2 is going to be negative 1. So you basically have 2 minus 1 to give you an answer of 1 there for your final velocity. All right, let's do it for 6 seconds. So instead of writing all that out again, which you could, let's start by just doing our problem where we left off. So 2.0 meters per second plus, this would be our acceleration number here. We are accelerating at the negative 0.5 meters per second squared, 0.5, 0.5. And then this time, instead of multiplying by 2 seconds, we're going to multiply by 6 seconds. So negative 0.5 times 6 is actually going to be negative 3. So it's basically 2 minus 3, which gives us a negative answer. And our negative answer is negative 1 meter per second. So what is the ball's velocity after 6 seconds? It's now negative 1 meter per second. Negative just means it's moving the other way. Awesome. Number 10. Yeah, I'll show you number. Yeah, we'll do number 10 too. So a bus is traveling at 13.4 meters per second, which is the equivalent of 30 miles per hour. We won't need that in this case. And it's accelerating at a constant rate of 3.5 meters per second squared for 7 seconds. What is the velocity of the bus at the end of that time? Awesome. So just like the previous problem, we're going to have to solve for final velocity. So we're going to use this same equation that is up here for final velocity. It's just your initial plus acceleration multiplied by time, which in this case, I'll just rewrite the formula first. Final velocity equals your initial plus acceleration multiplied by time. It says the bus is traveling at 13.4 meters per second. So there's our initial velocity, 13.4 meters per second. I just put it in right there. Plus acceleration, which our acceleration is that 3.5 meters per second squared. And our time is the 7 seconds. And this is how you would set it up. And when you do your math, you should be getting a number . Yeah, 13.4. Yeah, should be getting a number in the upper 30s. Won't tell you what it is, but it will be meters per second. I'll give you the unit. Number 11, I'm not going to do it for you, but we can talk about it. It says if a car starts from rest, so 0 meters per second. But yeah, anytime it started from rest, 0 meters per second, it tells us your acceleration. It does not tell you how much time will be required, so you don't know the time. And you do know that you want to reach 28 meters per second. So with this one, I better give you the time formula. Here's the time formula that you're going to use. Final velocity minus initial velocity all over acceleration. So it looks very similar to the acceleration formula, but you can see that these two variables here just swapped places, which you can do, So solving for time, plug in your numbers there, and your answer will be in seconds since you're solving for time. Number 12, Joe Physics is out for a drive and slows down from x meters per second to 3 meters per second, and that happens over the course of 9.05 seconds. If the acceleration was 2.1 meters per second squared, how fast was Joe driving at the beginning? So you could probably tell by the x, but we're looking for VI. What is our initial velocity?